Section 2.2, Linear Functions, Graphs, and Slopes. A linear function f is any function that can be described by the equation f of x equals mx plus b. Consider the graphs of 2x and 2x plus 3. Notice that the red graph is y equals 2x and the blue graph is y equals 2x plus 3. So what's the difference between these two graphs? They have the same slant or slope, so they are parallel. The only difference is where they cross the y-axis. In general, the graph y equals mx plus b is a line parallel to y equals mx, passing through the point 0b. The point 0b is called the y-intercept, the point where the line crosses the y-axis. So y equals mx plus b, m is the slope, and b is the y-intercept. The number that is in front of x is the slope. M is 2/3. That's a positive slope, so that means when we draw this line going left to right, it will be going uphill. What is the y-intercept? That's the point where the line crosses the y-axis. It's always 0, x is 0, and if x is 0, it will cross the y-axis at the point -17. b, the last number by itself, is always the b value of the y-intercept. F of x equals 8.9x plus 11. What is the slope? It's the number that's in front of the x, 8.9. That's positive, so once again, this line will be going uphill if you draw it from left to right. What is the y-intercept? It is the point 0, 11. Whatever the number is at the end, that's what goes here in the y-intercept. The equation y equals mx plus b is called the slope-intercept form. The slope is m and the y-intercept is 0. Let's find the slope and the y-intercept of these problems. So our first problem, y equals 8x minus 3. Do you know what the slope is? 8. It is the number that is in front of the x. Do you know what the y-intercept is? It's always 0 in parentheses with the number that is at the end of the problem, -3. 5x plus 7y equals 14. We can't just look at this problem and tell what the slope is because it is not in the form y equals mx plus b. We want it to be in that form, and then we can easily identify the slope and the y-intercept. How can we solve for y? We need to isolate the y term. We can do that by subtracting 5x from both sides. That gives us 7y equals -5x plus 14. We need to isolate the y. We will do that by dividing everything by 7, and that gives us y equals -5/7 x plus 2. So what is the slope? The number in front of the x, -5/7. What is the y-intercept? 0, 2. Our final example, y equals 2. It's in the right form. It's y equals. What is the slope? There is no x. You can almost think of it as y equals 0 times x plus 2. Look at it that way if you want to, and then you can realize that the slope is 0, and the y-intercept is the point 0, 2. So, slope is a measures a line's slant. How slanted is the line? The slope m of a line passing through the points x1, y1, and x2, y2 is defined to be m equals y2 minus y1 over x2 minus x1. And you can't have x1 equal to x2 because that would cause division by 0. Slope can also be thought of as rise over run or rate of change. If a line has a positive slope, then the line will be going uphill as you draw it from left to right. So a positive slope might look, line with a positive slope might look like that, like that, like that, like that. It just has to be going uphill as you draw the line from left to right. A negative slope will be going downhill as you draw it from left to right. So think about all the possible negative slopes. Zero slope. There is no slope. We just saw an example of that. Y equals 2. Zero slope, horizontal lines. Undefined slope. That's where x1 equals x2. It's where you have a vertical line. Any vertical line has an undefined slope. So a zero slope will be a line that's of the form y equals some value. Let's call that value b because that's where it crosses the y-intercept. Undefined slope will be vertical lines, which will be x equals some value. We can call that one c. X equals something, we'll call it c, some value. So now let's find the slope of the line that passes through the points -2, 5, and x, or in 3, -3. It doesn't really matter which point you designate to be x1, y1, and which point you designate to be x2, y2. You can choose either one, just make sure you're consistent. So our slope is going to be y2 minus y1 over x2 minus -2. Just make sure that 3 and -3 are in the point together. Make sure they are over top of each other in your equation. -2, 5 are in the point together. Make sure they're over top of each other in the equation. So that gives us -3 minus 5 is a -8. 3 minus a -2 is 3 plus 2 is 5. So our slope is -8/5. I just want to demonstrate that we could have done it a different way. If we had chosen for our blue point to be the first point and our red one to be the second one, we could have said 5 minus a -3 over -2 minus 3. Suppose we had chosen the points the other way. That still gives us 8 over a -5 or -8/5. So it doesn't matter really which point you choose to be the first one and which one you choose to be the second one. So find the slope of the line that passes through those points, plot the points, and sketch the line. So -2, 5, and 3, -3. -2, 5, and 3, -3. That's our line, sort of. And sure enough, that's -8/5 is our slope. And if we think about it being rise over run, we could go down 8, that's our rise, over 5, that's our run, and it's going downhill left to right. Find the rate of change. Remember, rate of change is another word for slope. Find the rate of change of the volume of mail going through the U.S. Post Office. So we want to designate one of these points, x1, y1. It doesn't matter which one. We could call that x1, y1. We can call this x2, y2. It doesn't matter. So our slope will be y2, 202.7 minus y1, 213.1 divided by x2, 2008 minus x1, 2006. So that gives us m equals positive 10.4 divided by negative 2, or our slope is negative 5.2. And you can look at the graph and see that it's going downhill left to right. So it makes sense that that slope is negative. And that's all of section 2.4. Let's move on to the next section.